Hi, my name is Venkatesh.
And my name is Madhavan.
Together we are going to introduce this course which is called Computational Thinking to you, which is the first starting step to learning programming actually. And the reason we are calling it computational thinking is because before we start doing any programming work, we got to organize our thinking in a very specific way, so that this thinking process is systematic and can be communicated to another person or to a computer or whatever it is, for which thought process has to be organized in a very specific way, and all that we will teach you in this course essentially is to help you to organize your thought process like this.
So we must remember that a computer is just a very precise machine which can execute some commands that we tell it to, like to add some numbers or to divide some numbers or to move things around, rearrange something. So what we are really doing when we instruct a computer through a program is to follow a specific sequence of steps to achieve some goal. So this is nothing very special about computers. The same thing happens when we talk to somebody else about how to do something. For instance, if you have ever experienced a cooking show or cooked yourself, then you would follow a recipe. So a recipe for cooking is just a sequence of steps. It tells you what are all the ingredients that you need, then it will tell you how to process these. It will tell you to chop something fine, it will tell you to put something into a mixer and grind it into a powder, and then it will tell you to heat something, put something. There will be a sequence. You add something first, add something second, and of course how much detail these instructions are depend on what is the expected understanding of your level of expertise. So if I think you are an expert cook, I would just say chop something fine. But if I think that you are cooking for the first time, then I might tell you that by fine I mean that each piece must be roughly say 2 millimeters by 2 millimeters, or it should be 5 millimeters by 5 millimeters. So let us take an example. So suppose I am trying to arrange a function in a hall, and I want to get this hall ready for the function. So if there is a team of people who do this regularly, right, then I just have to tell them the function is going to start at 10 o'clock tomorrow, there will be 50 people, please get the hall ready, and this will be enough. But supposing this is a new team, a people who have never done this before, then I have to be much more elaborate. I will have to say maybe that you should make sure that the hall is cleaned half an hour before. If it is warm weather, maybe turn on the air conditioner at 9:30. Then if there are supposed to be 50 people, how do you arrange the chairs? I might have to say put the chairs in 10 rows or in 5 rows with 10 chairs per row, but then keep a gap in the middle. So you have 5, a gap and 5. So depending on how much I expect the person who is going to understand and do the instruction, execute the instruction, how much they can do without further explanation, I will give a suitable level of instructions. So this is what we do when we talk to computers. So we tell it certain steps, and those steps are based on our understanding of what the computer can do easily, like add, subtract, flip left and right and so on. So this is the language of talking to a computer, and this is programming. So in this course we are not really going to talk about specifically programming in any one language. We are going to discuss rather the general steps that we use when we do computational things which will eventually be done on a computer.
So as Madhavan explained, the whole idea of doing programming is to convert a given problem into a sequence, a procedure which is basically a sequence of steps. And what we will find while we do this course, what we will find interesting is that there is a pattern for a problem. When you look at a problem, the problems do not all look very different actually, they all fall into certain patterns. And when I say patterns, what it means basically is that the sequence of steps for one problem can look very similar to the sequence of steps that we use to solve another problem. And so basically if you do one pattern, if you find for a single problem we find the pattern which is what kind of steps that we need, then one might be able to take these steps and apply them to a completely different problem coming from a very different problem domain, right. And this pattern can be simple for simple problems and can be extremely complex for complex problems. So there can be a gradation in the complexity or the difficulty of the pattern, right, in some sense. So just as an example, consider for example, at home we dry clothes and so on. So we get the clothes from the washing machine, so it is in a bucket or in a tub, and we have these clothes lines, and we need to take out these clothes and hang them on the clothes line. So if we go about it haphazardly, you might take the clothes and hang them, and then after you start hanging them on the clothes line, you will find there are gaps between the clothes that you have hung there, and so you have to find the appropriate cloth that will go in that gap, right. So to make it easier, what you might say is that let me start to do it in a more systematic way. So let me start in the clothes line from the left to the right. So I take the biggest piece of cloth that is there, hang it on the left side, put a clip, then pick the next biggest one, put it next to it, put a clip and go like that. And at the end, when I have a small piece of space, I will find the most appropriate cloth that can hang in that place, and so I fill that cloth line and then move to the next cloth line. So that can be one way of doing it. So this is a pattern, this gives me a pattern. So the pattern basically says look for the biggest piece of cloth, hang it on the left side of the cloth line, this is a pattern. Now if you look at another problem, for example, I have a bunch of books that I have in a box, and I have 3 shelves, and I want to put these books on a shelf. Again I have to do something, right. I have to pick something and put it on the shelf. Again I can do it haphazardly, or I could do it systematically. I can take the biggest book, keep it on the left side of the first shelf, and then put the next biggest book next to it, and so on, and go like that. And if you look at the pattern for the books, it looks very similar to the pattern for the clothes, how you hang the clothes on the line. So in a sense, there is, even though the problem statements are very different, right. One is saying arrange books on a shelf, the other problem is saying hang the clothes on a line. The way you approach these problems can look very, very similar, and a single pattern you might be able to write which does both. So that is what we are going to explore in this course. How do we find these kind of patterns which solves a very large class of problems coming from different domains.
So in order to illustrate these patterns and how we move from simple problems to more complex problems, what we will do is we will work with some sets of data. So in our next lecture, we will look at these data sets in detail and explain exactly what we are going to do, but just to give a quick introduction, we have these cards. So we have some data about school marks, so we have cards representing the marks of students in a class. We have some shopping data which talks about shopping bills and how customers spend on their bills, and when we have some data taken from a paragraph of text where we talk about words and how many letters there are in each word and what type of speech and all that. And using these different very simple pieces of data, we will illustrate these ideas about looking for patterns and computing quantities in a systematic way.